So this 3-5 worksheet is in Google Classroom. So let's open it. We'll do the odds, and then it's your responsibility to finish it. Now, this worksheet is kind of the culmination of all the things we've done so far. So you're going to see things moved left to right, flipped around, stretched, compressed, all of those things are going to be happening. So to deal with it, I think this is the easiest way to approach it. So let's take a look at number one. The parent function for number one is the outside function that we see. So if you take a look at what we see here, we see this squared. And so our parent function is g of x equals x squared. Now it says to graph both f and g. So without a table, you should know, remember I taught you those 3 points. If you want to be more accurate, you can plug in more stuff, but I want you to draw your parent function. And then since you're doing it on the iPad, switch colors for me. Pick whatever colors you like. And this is the next thing I want you to do. Take whatever is stuck on the inside. We're going to ignore the outside for our first step. Whatever is stuck on the inside of the function, so inside the square, inside the absolute value, inside the cube root, that affects our x's. So that's the first thing we have to figure out what happens. So what I want you to do, remember our good x's were originally -1, 0, and 1. So I want you to put that equal to -1. Give yourself a little bit of room. That equal to 0. That inside equal to 1. And then you're just going to solve each one. Now, if you know the pattern, you see the pattern, you're going to see what happens. This first one, when we subtract 3 from both sides, we get -4. The next one we subtract 3, we get -3. The next one we subtract 3, we get -2. So the x's we want to use for this particular function are -4, -3, and -2. Now let's not go any further. Let's first take and let's think about what we think is going to happen to this function. There is an inside addition, so this function should move left. And then there's an outside addition, so this function should move up. So technically, since there's a plain old x with the +3, it should move left 3 and up 1. Now, how can we check that that's true? We're going to take these in, we're going to plug them into here, following order of operations. So if I plug in -4, I get -4 plus 3 squared plus 1. Now, you don't have to write each one of those down, but if your algebra sucks in your head, write it down. So -4 plus 3 is -1, but when I square it, I get 1, and then 1 plus 1 is 2. And then if I plug in -3, I get 0 squared. Plus 1 is 1. And then if I plug in -2, because of the symmetry of a parabola, I better get 2 again. I should get this matching value. Those two should always match. If I get -2 plus 3 is 1, square it, get 1. 1 plus 1 is 2. So probably I'm right because I see that this matches. Now in a cubic, they're going to be opposites. In a square, they should be the same. So let's draw it. So over here at -4, I'm up at 2. Over at -3, I'm up at 1. Over at -2, I'm up at 2. So as you can see, my prediction that it's going to go to the left and up is perfectly correct. Nothing else has changed about the function. So that's what I want you to do for these. Do we have any questions about number one? Yes?
I know you probably said it already.
Yeah.
I just want to make sure.
No problem.
How did you find the f of x's? Did you put like -4 squared?
Yeah, okay, so again, let me remind you. So to find the x's, we are gonna set the inside equal to -1, 0, and 1 and solve. To find the y's, or the f of x's, we are going to stick those 3 values. So -4, I'm going to put it here and do the algebra. -3, I'm going to put it here and do the algebra. -2, I'm going to put it here and do the algebra. And that will give you the y's. So you're just going to take those three values, plug them back into the function to find the y's that match. Input those. Okay. Any other questions about number 1? That was a good question. Anybody else? Okay, let's do number 3. In number 3, what is our outside function? What is our parent function for number 3? What do you think? The execute. Now, let's look at our function and see what we think is happening. There's an addition on the inside. That should move it left. There's a negative on the outside. That should flip it across the x-axis. Okay. Now, we didn't have to write those descriptions, but it's really good as a way to check your work. So what are we going to do first off? Well, we are going to set the inside. So x plus 1 equal to negative 1, x plus 1 equal to 0, x plus 1 equal to positive 1. And we're going to solve each one of those. Every single time, how do we move this 1 to the other side? If there's a plus 1, what are we going to do to get rid of it? We're going to subtract it every time. And so our first one becomes negative 2. Negative 1 is our second one, and 0 is the third one. So the values we're going to plug into this function, the inputs are going to be negative 2, negative 1, and 0. Now, where are we plugging those in? Well, we're plugging them into the f of x function. And so we're going to plug those in. Now, you can do the math. You can actually write down on your page the opposite of negative 2 plus 1 cubed. Negative 2 plus 1 is negative 1. Negative 1 cubed has to be done first before we take the opposite of our answer. Negative 1 cubed is negative 1. The opposite of negative 1 is 1. So our answer here is 1. If we plug in negative 1 and we get 0, cube that, still gets 0. The opposite of that is 0. Plug in 0, we get 1. Cube it, get 1. The opposite of that is negative 1. So let's graph our original function, our parent function g of x. Remember, the 3 good points are those ones you see there. And now we are going to graph the new version. So at negative 2, we're going to be up 1. At negative 1, we are at 0. At 0, we're at negative 1. Now, we should have predicted, we already talked about the fact that it's moved to the left and flipped over the x-axis. So you can see how this one moved to the left. Oh, I'm sorry, that was ugly. And then got flipped upside down. So what we're predicting actually did happen. There is number 3. Does anybody have any questions about that? Okay, let's go to number 5. This one's kind of an interesting one. We don't think about the fact that a linear function is transformed from g of x equal to x. But that is how every line that we ever draw has some sort of relationship to this one. So our identity function, remember, our identity function is just that perfect line that cuts through the first and the third quadrant. So what happens to it if we look in the way, in the light of transformations, like we see it, just the way transformations work? The 2 is stuck to the x. When a 2 is stuck on the x, it makes the, whatever the shape is, get closer to, let me go right here and here. it's going to make this line closer to the y-axis. It's going to compress it closer to the y-axis. And then this one is going to be going to take the line and drop it down 1. So it's going to be compressed horizontally, and it's going to go down 1. Okay. Now, this is a line, and if you recognize that it's a line, it doesn't matter what x's we plug in. But let's actually use the same sort of thinking we did for every other one. So we're doing the same thing consistently. So if I were graphing this line, I would start at -1, go up 2 over 1, up 2 over 1, make a line, you know. Or I'd plug in -1, 0, and +1. Just plug in whatever you want. It's a line. It's so nice. You can do whatever the heck you want to it. But if we do the same trick we were doing before, we should set 2x equal to -1, 2x equal to 0, and 2x equal to 1. Now that's what we should do. But again, there's the horrible saying, there's lots of ways to skin a cat. You don't have to do every problem the same way. You might do it one way, I might do it the other, we might get the same exact answer. Okay, so what do you do to get rid of that 2? So here's why x's, anything we do the x's, it's the opposite of what we're thinking, because we have to divide off the 2. It was multiplied, but we do the opposite, we divide. So technically our good x's are -1/2, 0, and +1/2. And then that's what we should plug into our function. So 2 times the value minus 1. 2 times the value minus 1. Well, 2 times -1/2 is -1, minus 1 is -2. 2 times 0 is 0, minus 1 is -1. 2 times 1/2 is 1, minus 1 is 0. Now it's linear, so these should be equally spaced and these should be equally spaced. Or you did something weird. Let's graph our line and let's see, was it compressed closer to the y-axis and did it drop down 1? Well, at -1/2 we are down 2. That first point is closer to the x-axis than it used to be, and it went down. 0, we're down 1. And at 1/2, we are at 0. So technically, yes, what we predicted happened. Okay. So what happens? This line is now closer to the y-axis, and its kind of center point got scooched down 1. But again, it's a line. Yeah, draw it how you want to draw it, okay? We might come back and do 6 because it's a reciprocal function, which is always wonky in the thinking. Anybody have any questions about what we did for 5? Make sense, kind of? Okay. Let's do 7. That is a cube root, if you couldn't read my writing. That is a cube root. That is a 3. Okay, so our parent function is the cubed root of x, which normally we draw with the same points as a cube, but it's the swoop to the right in the first quadrant and a swoop down in to the left in the third quadrant. Okay, so that's what the parent function looks like. That's why we study those. Now let's discuss what we think is going to happen. Subtracting 1 on the inside should move it to the right. And adding 2 on the inside should move it up. Okay, so remember what we're going to do. Inside equals -1, inside equals 0, inside equals positive 1. Now, if you can do that in your head, yay, go for it. But it's not a bad idea to write some things down on paper. We're going to add 1 to both sides to get the x by itself. If I add 1 here, that's 0. Add 1 here, get 1. Add 1 here, get 2. So our good x's to plug in for this particular function aren't negative 1, 0, and 1 anymore. They are 0, 1, and 2. Now remember, they're going to go right inside, and you're going to input them, see what values we get out. Oh, yeah, it'll work. Okay. I was thinking, oh, cube roots, but we're okay. So if we plug in 0, we get negative 1. The cube root of negative 1 is negative 1. Plus 2 is negative 1 plus 2, or 1. So this value right here is 1. Okay, let me tell you again. If I plug in 0, I get the cube root of negative 1, which is negative 1 plus 2 is 1. Now let's look at 1. 1 minus 1 is 0. The cube root of that is 0, plus 2 is 2. So that's a nice, you always love the 0 one. And then if we plug in 2, the cubed root of 1 is 1. 1 plus 2 is 3. So that stuff, if you want to write down the inputs to help you clarify what happens, do that. These are what, I at least need to see the table, but it's kind of your decision what you plug in. Okay, now we're ready to go. So at 0, I am up at 1. At 1, I am up at 2. At 2, I am up at 3. Make your swoops. You'll notice that we've had very little as far as compressions or stretches. Those are my least concerns of all the concerns I have about making sure you can graph these. Did what we predict come true? Yes, we moved to the right one. We went up 2. If you compare this center point to this center point, that's exactly what happened. Any questions on number 7? Okay, let's go to number 9. Oh, good, we at least get a reciprocal function. Okay, so this one is our reciprocal squared. So the parent is 1 over x squared. Let me remind you how that works. At the x and y axis, there is an asymptote, meaning this function never touches those things, and those are barriers that we cannot cross. At negative 1, because when you square a negative, you get a positive, we're up at positive 1, and there's a swoop right here. Bless you. At positive 1, we're at positive 1, and we get a swoop right here. So it looks very much like our reciprocal function. This piece, because when we square it, it becomes a positive, that's why it went up here. Okay. Now let's predict what happens to this function. For this function, we have an addition on the inside of the function. What did we say happens when we add on the inside? What happens to something when we add on the inside of the function? Yes. Yes, so this is going to move to the left. There's no other change in the x, so we should predict that it moves exactly 3 units to the left. What should we do? Well, we should put x plus 3 equals negative 1, x plus 3 equals 0, and x plus 3 equals positive 1, and we should solve. Each time we are subtracting 3 from the original good 3. So if I subtract 3 from negative 1, I get negative 4. Subtract 3 from 0, I get negative 3. Subtract 3 from 1, I get negative 2. And now just let's list those x's. These are the x's I want to graph. Negative 4, negative 3, negative 2. Now remember, we are plugging into our new function those values to see what we get. When I plug in negative 4, I add it to 3, I get negative 1, but it's inside of a square. Negative 1 squared is 1. 1 over 1 is 1. When I plug in -3, I get 1 over 0. That's undefined. That's where our vertical asymptote lives. And if I plug in -2, I get 1 squared in the bottom. That's 1 over 1, which is 1. Now, for one like this, I always move my asymptotes first. So this asymptote hasn't changed because I haven't moved my graph up or down. If there was a +2 out here or a +3 or a -1, I would move that asymptote, but there's nothing out there. And then this asymptote needs to scooch over 3. This verified that for us. So over here at -3, please put that asymptote on. So when I am doing any type of reciprocal function, whether it's the reciprocal or reciprocal squared, I always move the asymptotes before I put any dots on the graph. Now let's put the dots on the graph. At -4, I am at 1. At -2, I'm at 1. Why? Well, there's a swoop here and a swoop here. As you can tell, I have picked up this function and I have moved it 4 to the left. I have changed, or 3 to the left, I'm sorry. We haven't changed anything else about the function. So when moving, shifting, changing a reciprocal function, always move the asymptotes first. This one move if you add or subtract on the inside. This one moves if you add or subtract on the outside. Yes. Number 11. This one, its parent, we're just going to call g of x equals c. It's a constant. And so just pick any value you want, put a little c there and go bink. And you don't have to plug in anything, but if you have the urge, -1, 0, and 1, into that is always going to be 2. It's constant. It's constantly 2. And then you can just graph it. At -1, we're at 2. At 0, we're at 2. At 1, it's 2. It's not really, you can't really describe it too much. You can just say it's a horizontal line at 2. I don't know. But I was trying to pick one of each type that we had. Okay, that was an easy one if they only were all like that. And so now we've done all of the odds. So this assignment is halfway done. You still have half the class period left, pretty much. So I want you now to finish this up. Remember, you have this assignment needs turned in, and then the 3 ones from before, from part 1, part 2, and part 3.